All right, 23, we got our vertical motion model. So we have our equation here. Again, that's initial velocity, that's initial height. So I'm going to rewrite this as negative 16t squared plus 48t plus 6. Again, 48 was my initial velocity, and 6 was my initial height. So that's the equation. What we are asked to do then is to find the maximum height, or in other words, the vertex. So we ended our last video by finding the vertex of something in standard form. We're going to do negative b over 2a again. My b value is 48, times 2 times my a value, which is negative 16. So this is negative 48 over negative 32. That simplifies to 3/2, or 1.5. So that we're going to then put into the equation. Negative 16, instead of t, we go 1.5, and again that's squared, plus 48, instead of t, we'll go 1.5, because that's the t that we want, or the time we want, and then plus 6. When we calculate that, we do everything again, order of operations. This part would have to be done first. Then we'd multiply that by negative 16. I would do this part together. And when it's all said and done, we get 42, or 42 feet. So we find out that this thing at 1.5 seconds was at 42 feet, or a value of 1.5 comma 42. All right, looking at 24, we are trying to determine if it is linear, exponential, or quadratic. Again, we are looking there for first, second difference, or a common ratio. So negative 6, negative 2, 2, 6, and 10. What's happening? So negative 6 to negative 2 is plus 4. Negative 2 to 2 is also plus 4. 2 to 6 is plus 4. 6 to 10 is plus 4. So this is linear. First differences are the same. If our second differences were the same, that would be quadratic. And if there was a common ratio, multiplied by the same thing, that would be exponential. All right, 25, solve by factoring. So if we're going to solve this by factoring, the first thing we're going to do is factor it. So I'm going to put 21 up top. I'm going to put 10 down there. I need two numbers that multiply to 21 that add to 10. That's going to be 7 and 3. So we've got x plus 7, x plus 3 equals 0 as our factor trinomial. Again, both of these pull out to be set equal to 0. We'll subtract 7 on the left one, and we get x equals negative 7. That's the solution. We'll subtract 3 on the other one, and we get x equals negative 3. That's another solution, and that's it. That's all we've got to do. We got another one that we're solving by factoring. So again, let's put the c value of negative 14 up top and the b value of 5 down below. We need two numbers that multiply to negative 14 that add to 5. One's going to be positive, one's going to be negative. I think 7 and 2 will work. I think positive 7 and negative 2 will work. So we've got x plus 7, x minus 2 equals 0. Again, remember, these values are not your solutions. They get you to here. Then we take those, set them equal to 0, and solve. Minus 7, x equals negative 7, plus 2, x equals 2. And there's your two solutions. Square root property here. To solve this quadratic, x squared equals negative 49. I can't solve that. I don't have a real solution there because I can't square root a negative number. So we say no real solution for that one. If If it was x squared equals 49, then we square root both sides, we would get x equals positive or negative 7. But because of this negative here, didn't matter what the number was after it, x squared equals negative, anything is no solution. Solve this quadratic. So we're going to do this. We're going to use our square root property here. But before I do that, I got to get the x squared by itself. So I'm going to add 140 to both sides. So I've got 5x equals 140. I'm going to try to get x by itself, or x squared by itself at least. So I'm going to divide by 5. X squared equals 28. Now, like in the last problem, we'd say, hey, if I can square root 28, great. I'd be done, but I can't. So I'm going to put my square root signs on both of these, leaving me x equals plus or minus the square root of, whoops, back that up a second. The square root of 28. Then we try to simplify the square root of 28. And we can say, hey, I know that square root of 28 is the same thing as square root of 4, square root of 7. And I know that the square root of 4 is 2. So square root of 28 would simplify to square root of 4, square root of 7, which would simplify to 2, square root of 7. So we put our plus or minus in front. 2, square root of 7, and call it good. 29, we're going to complete the square. So we already have nothing after the 4x, so that's good. Normally, or in some problems, we'd have to move something from here over, but we don't have to here because there's nothing there. So we need to figure out what value will go there. Remember, it's half of the b value, so 4 minus 2, and then squared. So 4 over 2 is 2, and 2 squared equals 4. So this is 4, and if we put it there, we also got to put it there. Now again, it isn't 4 because of this 4. It's 4 because we take half of this value and then square it. So if that were, let's just say 10, if it was 10x, we would take 10 divided by 2, which is 5, and then we'd square 5, which would be 25. And that's what would go there and there. But that isn't the case in this problem. So we've got x squared plus 4x plus 4 is equal to 25. This is a perfect square trinomial on the left side, so we're going to go x plus 2 quantity squared, and it's a 2 because that's half of this. Whoops, scrolling down. So again, this value here is always half of that number, and we don't really care about that number, it doesn't really matter. So it's still equal to 25. I will square root both sides. When I square the left side, I just lose my square. When I square root my right side, I get square root of 25, which would be plus or minus 5, because the square root of 25 is 5. And then I'm going to subtract that 2, and I'm going to subtract the 2, and that goes in front of my plus or minus. So I've got x equals negative 2 plus or minus 5, and because those are numbers, we can do negative 2 plus 5 and negative 2 minus 5. Negative 2 plus 5 is 3. Negative 2 minus 5 is negative 7. And those become our two solutions. 30 says simplify these two radicals. So the left side's already simplified except for the x to the third. And then we've got our x to the fifth. We're going to actually merge those back together in a second here. And we're actually going to multiply these two together as well. So we're going to do 3 on the outside, but then we're going to put these together. So 2 times 8 is 16. And x to the third, x to the fifth, those actually get added to give us x to the eighth. So we know that the square root of 16 is just 4. So that 4 gets multiplied with this 3, or 12. And then here I've got x to the 8th. I'm going to simplify that. And in x to the 8th, there would be 4 pairs of x's. 1, 2, 3, 4. And again, we want to get pairs of x's out. And the number that goes there is how many pairs we have. And we don't have anything in the square root left. Everything came out, so there's no square root. 31, use the quadratic formula to solve this. Quadratic formula, x equals negative b over 2a is our first part. So we're going to have negative 2 over 2 times a, which is 1. Negative 2 over 2 is the same thing as negative 1. And then we'll do b squared minus 4ac all over 2a. Square root of b squared, I should say. My b value is 2. Minus 4 times an a value of 1 times a c value of negative 24 all over 2 times the a value of 1. So let's start to simplify that again, holding on to that negative 1 up there. 2 squared is 4. Negative 4 times 1 times negative 24 is 96. So I've got 4 plus 96, or the square root of 4 plus 96, all over 2 times 1, or 2. Square root of 4 plus 96 will be square root of 100 over 2, and the square root of 100 is 10. So 10 over 2, or 5. So there's our two parts. I've got negative 1 plus or minus 5. Negative 1 plus 5 equals 4. Negative 1 minus 5 equals negative 6. And those are my two solutions. 32, solve the system using your choice. We can use, whoa, I went all the way to the beginning. Let's use substitution here, and let's take that x squared and sub it in for y. So we'll go x squared minus 4 equals 2x minus 1. Now to solve this, we want to get everything to one side, and it really doesn't matter which side we work to, but let's make the right side 0. So I'm going to subtract 2x, and I'm going to add 1. So I've got x squared minus 2x minus 4 plus 1, or x squared minus 2x minus 3. And the right side, 2x minus 2x and negative 1 plus 1 is 0. So now the task at hand is to solve this, and we would solve this in whatever form seems appropriate. I'm going to try to solve by factoring because the a value is 1. So I'm going to put a negative 3 up top and a negative 2 at the bottom. I need two numbers that multiply to negative 3 that add to negative 2. I know I've got to have negative and positive. I know 3 and 1 could work. And if the 3 is negative and the 1 is positive, that sure enough adds to negative 2. So x minus 3x plus 1 is our factored form. As we've done before, we'll solve these. This would be x equals 3, and that would be x equals negative 1. Now we need y values for both of those. So again, I'm going to sub into one of my two equations. I'm going to use the easier one, which is the 2x minus 1 here. 2 times x, which is 3, minus 1 is 6 minus 1, or 5. 3 comma 5 is the solution. 2 times negative 1 minus 1 is negative 2 minus 1, which is negative 3. Negative 1 from the x and negative 3 from the y is another solution. Again, remember, we're going to have 2 because we are solving a system for a quadratic and a linear. There should be 2 points where those things cross. So there is the final. That's the practice. If you can do those questions and do those pretty efficiently, we should be in great shape on the final.